Okay, this problem right here is on page 14, number 11, and this one we are allowed to use our calculator. So I'm not sure if you realized that when you started, but you get to use your calculator. And it says a particle moves along the x-axis so that at time greater than or equal to 0, the position is given as this. So since I'm allowed to use my calculator, I would go into my calculator and type in that position function into y1. And then it says, find for what values of t is the velocity increasing. Velocity is the derivative of the position. So I'm going to show you what I've got in my calculator. And let's see. Okay, so into my y1, I put my position. Into my y2, I asked the calculator to take the derivative of y1, which becomes the velocity. Notice I turned off y1. I no longer have the equal sign highlighted. And when I hit graph, it's going to graph the velocity. I'm going to look and see where this velocity happens to be increasing. I also want to show you the window that I'm working with. I set my X window on purpose before I began because if I look at all my choices for t, which is like my x-axis, they go from 0 up to 3. So I just made mine -1 to 5 so I can see that. My y's I played around with a little bit. I've got mine -1 to 25. My x-res, remember whenever you're graphing a derivative, you want that x-res to be high. So when I graph, this is my velocity graph right here. And I wanted to know when this is the velocity. I want to know when that velocity graph is increasing. Well, it's increasing here and it's increasing here. So if I look at my answer choices, it looks like it's increasing from 0 to 1 and then from 3 the rest of the way. So given the choices, D would be the one that matched up. Okay, this one I'm moving to page 26, number 6. I do not get to use my calculator on this one. This is similar to the last one I did, but no calculator. Particle starts at time is 0 and moves along a number line so that the position is given here. The particle is moving to the right for which t values. When something's moving to the right, something I know about it is that the velocity of it is positive. So I need to get to my velocity, which means I need to take the derivative of this. So if I have x of t, my derivative is going to give me v of t. I'm going to have to do a product rule. Be careful when you run through this. This is your first. This is your second. Chain will show up. In the product rule, first, t minus 2 quantity cubed. Derivative of the second, which is just 1. And I didn't need a bracket. Could have done a parenthesis. Plus the second term, t minus 6, times the derivative of the first term. Now, when I take the derivative of this first term, I'm going to have to do the chain rule. 3 swings to the front. T minus 2 stays there and becomes squared times the derivative of the inside, which is 1. I don't need the 1 there. So if I write this a little bit nicer, I have t minus 2 quantity cubed plus 3 t minus 6 t minus 2 quantity squared. And if I want to figure out where this thing is positive, what I could do is I could set this velocity equal to 0 to begin with. So to solve this, I noticed that this and this term both have t minus 2's in them. So I'm going to factor out a t minus 2, and I'm actually going to factor out a t minus 2 squared from both of those terms that I underline with the squiggly line. If I factor it out of this first one, I'm just left with t minus 2. Plus, if I factor it out of this second one, I am left with 3 times t minus 6. These are going to be gone. I'm going to go ahead and distribute this. 3t minus 18. I'm going to keep simplifying here. 0 equals t minus 2 quantity squared. In the parentheses, I have 4t minus 20. And now I can set each equal to 0, and I get time equals 2 and time equals 5. So those are the two times when the velocity is 0. I wanted to know when the velocity is positive. So I will make a velocity number line. and I will put those 2 times on there, 2 and 5, and I'll test the velocity on either side of these critical numbers. So maybe I'll pick 1 and 3 and 6. And where I'm testing them is into the velocity, which is the derivative. I can plug them in any of these spots. This is by far the easiest spot for me to plug it in. And what's easy about this line is this first parenthesis is squared. So no matter what I plug in right here, I will always get a positive number. So I'm not even going to bother plugging the 1 into this parenthesis because I know it's going to be positive. So I'm just going to plug the 1 into this bracket. 4 minus 20 is negative. Let's put 3 in. 12 minus 20 is also negative. Let's put 6 in. 24 minus 20 is positive. Now the question asks, when is it moving to the right? Remember, when something's going to the right, the velocity is positive. So to answer the question, the velocity is positive. We're moving to the right from 5 up to infinity, or answer choice C. Okay, next up, I am on page 28, and I'm looking at number 15, and there's no calculator allowed. It says the slope of the tangent line to this curve at the point where y equals pi is what? So whenever it asks me for the slope, I want to take the derivative. I'm realizing that this has x's and y's in it, and I'm only given a y value. So the first thing I'm going to do is figure out what x is when y is pi, just so I have a point to plug in after I take my derivative. So I'm going to go in here, and I'm going to say 2x, and for y I'm going to plug in pi, plus the sine of pi is equal to 2 pi. You have to remember how to find the sine of pi. Remember, pi is over here. Sine is my y coordinate, so it's 0. That's just 0. So I have 2x pi equals 2 pi. If I divide both sides by 2 pi, I get that my x value equals 1. So now I have a full point. So now I'm ready to attack the problem of finding the slope. To find the slope, that just means the derivative. So I'm going to find the slope of this thing down here. I notice I have 2xy. I'm multiplying two things that have variables in them. I'm going to need product rule. First is 2x, second is y. So first term, 2x. Derivative of my second, dy dx. Plus my second term, which is y, derivative of the first, which is just 2, plus the derivative of sine y is cosine y dy dx, because I took the derivative of something with y in it, equals the derivative of 2 pi is just 0, because 2 pi is a constant. And then at this point, I'm going to plug in 1 comma pi. So in for x, I put in 1. So this becomes 2 dy dx plus 2 pi plus the cosine of pi dy dx equaling 0. I'm figuring out what the cosine of pi is. Well, remember this little unit, half unit circle I drew up here. Pi's over here, and the cosine is -1. So I have 2 dy dx plus 2 pi. This is -1 dy dx equals 0. And my goal is to solve for dy dx. I can combine these two like terms. 2 dy dx minus 1 dy dx is just 1 dy dx, or dy dx. Oops. Combine those, and I'm going to bring this 2 pi over to the right side, so it is equal to -2 pi, and my answer is A. Okay, the next one I'm going to do is on page 29, number 16. This one tells us what f of x is, tells us what g of x is, and then it asks us to take the derivative of f of g of x at x equals e. I'm actually going to figure out what f of g of x is first. Then I'll take the derivative, then I'll plug in e. So let's see, f of g was ln x. F means I come over here to f, and I rewrite it, e to the 2, and instead of x, I'm going to put in ln x. And then I'm supposed to take the derivative of that. I'm actually going to simplify that before I take the derivative. I'm going to condense this log. I see an E and an ln, and I really want to cross them out, but I can't cross them out until I get that out of there. So remember, a number in the front of a natural log or a log can be condensed by making it an exponent. So this is the same thing as y equals e to the natural log of x squared. Now I see two things that can cancel. So y equals x squared. The question was asking me to find the derivative. So y prime equals 2x. And then I'm really supposed to be finding the derivative at the value of e. So 2e, leaving me with answer choice C.